Now, I made up this practice problem for today. So there are some weird things with conditions that happen, but it's not that big of a deal. So this one says, I was trying to do something that would make sense of when to actually use this. A buyer for a t-shirt shop wants to compare the proportion of t-shirt sizes that are sold to the proportion that were ordered. They ordered 10% smalls, 10% or 20% mediums, 40% large, and 30% extra. The buyer counts the number of t-shirts of each size that are sold in a week. The number of t-shirts sold that week were 25 small, 41 medium, 91 large, and 68 extra large. The buyer wants to determine whether the proportions of t-shirt sizes sold are consistent with the proportion of t-shirt sizes ordered. As someone who owns a business, that would make sense to do, to want to make sure that like you're not just like randomly buying t-shirts with no reason. You want to do it to where you make sure that you're actually on track with what it actually is. So starting with state, probably just going to type. What's our first thing? What's the beginning of state? Population. So what would be our population for this problem? And this is where me making up the problem gets a little vague. Like, okay, well, I'm recording all of them, so my population is my sample, which seems kind of weird, but I think y'all are probably fine with that. So let's just go with all shirts sold at a given store in this week. So what is my next thing to do? Define my for that. So I'm saying the proportion of something. So we are dealing with the proportion what? We've already stated our population. So we know we're dealing with this store in this week. But it's going to be the proportion of say I heard size. Would you say other than that? All right, so we're comparing them to make sure they're the same. Me just saying sales was the ones that are sold, which is I'm just condensing it there. You don't have to say versus because that's what we're going to compare at the end, which a lot of y'all were saying as I was saying stuff. You're kind of thinking too much. We basically want to see, do they match? We're under the null hypothesis that they do match, and we're going to find out if they don't. So PI is the proportion of t-shirt sales for each size. Again, the wording is a little funny with the sales versus bought because of my wording. This one's pretty straightforward, but since it's our example, let's go ahead and say what would our first subscript letter be that would make sense. So this one's pretty straightforward, but I'd rather be more specific in an example problem than less specific in an example problem. And so I could do XL, or I could just say that X means extra large. So now my null hypothesis, I write out each one. So my first one is P what? PS. And we are claiming that PS equals what? And writing percents is fine. It probably makes more sense to do commas in between so it just doesn't look like things run together. My next one is P what? PM, and we're saying that PM equals what? And then so we're just writing these out. So I have PL, which is, and then my last one is for extra large, And we're claiming that that one is. So what do I write for my alternative hypothesis? You just write word for word, at least one of the PIs is incorrect. And then what else do I need? And this problem does not give us one, so we're just going to use. I'm just going to keep typing on here, and then I'll end up switching to this next slide, probably in the middle. All right, plan. What is our first step? I think I don't like this text version of chi. It just looks like an X. That should be chi. Chi-squared GOF test. Should it, if I tell you we are just dealing with chi-square problems, should it be hard to tell if it is a goodness of fit problem or not a goodness of fit problem? No, because your table is what? It's either one this way or one this way. The other one is going to be a two-way table and have more than one in each direction. What's my next step? What about random? Remember, I made up this problem. Random or not random? So this is the part where I said it's kind of an issue, but that just means what? Maybe this one group came by and I had some tour bus come by and it was all adult males that came by in this tour bus to buy t-shirts. Well, that's going to be a lot different than a different week, so it would make sense that we shouldn't technically generalize it, but I can still use it to help my business out to see if I'm on track or not. Next one is what? Which I need to check what? I'm checking to make sure that all of them are. All right, so I know that my chart is going to be like this. But now how do I figure out how many is for each? So this is the part that we did not add to the fourth step yet. How many, what do I expect about smalls? So I need to use the numbers that were given to be able to find my total, and then use that total with these percentages that are given. So, attempt my pen. They add up to 225. Y'all can do that. So I'm just gonna write over here on the side in. Not gonna work. 225. So how do I find what goes there? Not gonna work. 225 times 0.1. I would write that because it's your notes, but usually I don't need you to write that. So while we're at that point, let's look back at our generic that we just did. And so out here, how can I generally write that for each one of these, you multiply what by what? What's 225? And I multiply n by each of my what? So each one of those, it's a terrible color, is n times PI. And I would write that in my generic for my notes, is that to find each of these, I do N times PI. And again, I'm going to go through and do these so we're not rushing too much. 22.5. This one gives you 45. What's next? And if I'm taking this as a test and I'm doing this practice problem, what should I do at the end to make sure I didn't do something stupid? Add them up and make sure they actually equal 225. You'd be surprised how many people get something wrong because of that. My degrees of freedom for this problem. Did I finish? No, I didn't finish independent. I'm going to talk and then I'll post it. Independent 10% condition, I would do 225 times 10. That's where another place where it gets weird because I made up the problem. Like we know how many we sold, so we knew the population. So maybe like we could have sold that many, at least that many that week, or we had that many available or something. What's my degrees of freedom going to be? 3, because how many categories? 4. 4 minus 1 is 3. Chi-square, just look at your calculator really quick because we only got a couple minutes. It shouldn't take 2 seconds to click a button. Go to chi-square test goodness of fit. So stat tests down to B. Nope, not B. D. What is different about what it is asking me to do in this test than it was yesterday? You put it in a list as opposed to a matrix because yesterday it was a two-way table and now it is not. Could you type things in a matrix? Or could you type things in a list? I hope so. So you type in your observed and then you type in your expected and then your degrees of freedom and it does everything for you. So it ends up being easier than yesterday because we're not dealing with anything with matrix at all. Conclusion, again, should also be very, very easy. We shouldn't have any issues with that. The Google form, I'm just trying to figure out a couple things for before the AP exam. I have to give out a form that says, which I'm going to post that one in a second, but I'd rather explain it first. Has anybody talked with their AP classes? I'm just going to stop this.